Good day, people. This is your boy Eduardo Agbo, and welcome to Design Genius. On today's tutorial, we're going to look at water flowing through a valve, and we are going to make sure that there's a pressure drop at this level, since we have put a sieve instead of letting the water pass through easily. So at the end of this tutorial, this is what we are going to obtain. We are going to obtain water flowing from this point, passing through a pressure drop and going outward. Now, what are we going to get as data from this tutorial is that we are going to get how the velocity or the speed is going to change from one point to another. That's the velocity. And we are going to observe how this simulation is going to go out in a real life situation. So guys, it is on. Let's start. To start, we need to make sure that the geometry is closed, meaning that our structure here is closed. Now here it is closed, here it is closed. Now to work with SolidWorks Xflow, you need to make sure that you have activated SolidWorks Flow Simulation. Without much ado, the first thing I need to verify here to make sure that the simulation is going to go according to plan is that I need to calculate and see the path that the fluid is going to take. That's view fluid volume. Now observe here that this is the volume of the fluid, so the fluid is going to pass through here. So if you want to put something like the flow rate, you need to take into consideration the volume of the fluid, which involves the different diameters at the different points. So we are going to click on this arrow to continue. So I need water, I don't need air, so I'm going to continue with water. Now at this level, I'm going to take flow rate. So I'm going to take at this level the volume flow rate. Now you can decide to take mass flow rate, but the difference between the two is that rho is equals to the mass flow rate on the volume flow rate. So here we have decided to take 0.1 because we cannot go above 0.19 because the diameter of this structure does not permit us to go through that value. So I'm going to work at the conditions of standard temperature and standard pressure. That is 25 degrees Celsius and 1 atmosphere. So here it is in Kelvin, 293.2 Kelvin. So we are going to continue to 1 bar, which is 101325 Pascal or Newton per meter square. Now here we are going to choose this surface here, and we are going to continue. Now don't forget, this can work for any structure. Now after, at the end, I'm just going to calculate, and now it depending on the processor of your machine and the speed of your machine. Maybe for some machines it's going to take time, but for mine it does not take a long period of time because the machine is kind of fast and rapid. So this is what we're going to obtain. So guys, before we observe the animation, I'm going to explain certain things here. Now what is the aim of this annual simulation? So here, let's just say we have water flowing in here. Let's say there's a pump pumping water into this valve. Now at this level, we don't want the water to fall directly, so the water cannot pass here. So the water is forced to pass through these holes, through this opening at this sieve. That's why you see that when the water comes here, hits on the surface and it looks for the sieve to go downwards. Now observe something. So I'm going to take let's say a molecule of water at the point. So here is blue. Let us take our graph. These are graphs meant to interpret the velocity at different points. So here, let's say when water gets at this position, it momentarily come to rest. Let's say the velocity is 0 at a given point. So let's move forward to the next point. So from blue 0 up to this point, so we are at around here, we are around 27.9 meters per second. So when this molecule or particle of water get downward here, we have the gravity also acting on it. So let's say the energy becomes much, so we have rate at this level to where it becomes maximum before decreasing at certain points depending on where the molecule of water is going to fall. So I've just isolated the molecule of water. Now let's look for general how it happens. Normally when we have water flowing into here, water is going to pass through this opening. It's going to hit and try to rotate before going here. So I'm going to try to animate it with pipe so that we could see it clearly. So I'm going to take pipe, I'm going to animate. Now here's water moving into the valve. At this level, water is going to pass through the opening. So let me put water is going to pass up to observe here. There's a rotation motion occurring at this level, telling us that particles or water molecules that fall at this part is going to rotate and take more time for it to pass through, while water molecules that are going to fall at this position, they are going to hit for a while, they are going to go through. So this is very realistic. So let me take it again and let's observe. You have water molecules moving in, going to pass through this point. Some are going to fall here and they're just going to continue. Others are going to fall at this one that's kind of bent. So let's say like concave. You're going to discover that we have some other the particles rotating, and you discover that the diameter of rotation decreases with time. That is telling us that what the energy that the molecule of water possess at that time is also decreasing. So you see the diameter is large, it decreases. For the next rotation, it decreases, telling us that when the water falls with the influence of gravity and the energy from the pump, we discover that it has two sum of energy. Now energy at this level is high, but we discover that when it hits this surface, it's going to convert the gravitational potential energy to kinetic energy, and it's going to decrease and it's going to go out. So let me put the ball animation so that you can appreciate well what we are doing here. So this is what happened. Water gets in there, gets down, and water goes out. So based on the graph that we have here for the velocity, you can look at the speed of any molecule at any point in time. So don't forget, this is your boy Eduardo Agbo. Don't forget to subscribe to the channel. Now good news, we are working on a website where you guys could go there for us to work together on your project and on the design that you have going upstairs. Now don't forget, you can also generate the report over here. Generate the report for your analysis and you look at the report. So I'm going to try, let us generate the report and see what's there. So you are going to hit on this button, generate, and you're going to wait for your report to be generated. So when that is done, you're just going to save and you're just going to open your report. Now when that is done, once you've set your report, you open your report, you're going to see how your report is going to be represented. So with that done, guys, don't forget to subscribe. Don't forget to subscribe. Don't forget to share if you find this video interesting, and please hope I'll see you next week for an awesome tutorial. Don't forget, this is your boy Eduardo Agbo from Design Genius. Stay blessed.